chapter 4 is applications of derivatives, and we've already done a couple. So if I'm looking at chapter 4 here, you see indeterminate forms and L'Hopital's rule, we did that, right? You'll do a second half of that in Calc 2. And then Newton's method is 4.7. That's going to be the project only, but your first go-to is going to be read this section of the book, okay? So 4.7, read 4.7 about Newton's method. Now I'm going to explain it, okay? So, but read 4.7. You could also just do a Google search or a YouTube search, right? And listen to some other nerd talk about it, right? But the idea is it's used for finding roots, meaning zeros, x-intercepts, right? We okay with what I'm saying? So what we do is we're trying to find out where this hits the x-axis, right? So you remember finding roots before, right? Like the parabola when it goes up, when you throw a ball up in the air, where does it hit the ground? All of that type of stuff. So same idea, but with much more complicated functions. What we do is we guess, and we go up to the curve, and we draw our tangent line. I almost hit it. And that tangent line will give us the next guess. So x initial is the first guess, right? And then x sub 1, and we take a guess at what the zero is, right? We go up to the curve, draw the tangent line, where the tangent line hits is our next guess, and we rinse and repeat. So we know the equation of this green line, right? What is it? Y minus what? Yeah, I'll say sorry. Oh, f prime. This is f prime of x, right? And then times x minus that first x. But what is this y value here? Yes, but what is that? So it's the tangent line, right? No, it's everybody's okay with this being the tangent line, yes? So let me do it this way. Oops, sorry. Let me call this point x initial, y initial, right? And this one x1, y1. That'll make it a little bit easier. So y minus y1 equals m times x minus x1, right? And the x initial and y initial are now just written as x and y. But what I'm saying is, I know what y1 is. I know what y1 is, don't I? Yeah, what is it? What is it? What number? 0. 0. 0. You agree? Look at the green line. Yeah, 0, right? So, the opposite of y1 equals m times x minus x sub 1. All right, I know that x sub 1 is my new guess, okay? X sub 1 is my new guess. and the original guess was just x, right? So this is minus f of x equals f prime of x times x minus x1. And I want to guess, I want to figure out what x1 is. So I'm going to solve this for x1. Yes, you ready? So it was y1, right? Yeah. Oh, no, I screwed that up. You're right, thank you. That should be y minus y1, right? So I get f of x. That's it, sorry. The y1 went to 0, right? Everybody agrees. The y1 hits 0, right? Yes, yeah, it is y equals. F of x is y, right? But I want to do it this way. I want to remember I'm solving for this guy, right? Find the next x. So I'm going to distribute, right? I'm gonna divide. I got f of x divided by f prime of x equals x minus x sub 1. I'm going to move the x sub 1 to the left and the f of x over f prime of x to the right. And there it is. This is Newton's method. Defined, and I'm gonna call it x next, okay? So I got some function, right? That's f of x. Yes? I'm going to figure out the tangent line, so I need the derivative, right? So there's f prime of x, right? And it turns out that this will give me that next place that the tangent line hits the axis, right? So just stay with me right now, right? I took an initial guess, I found the tangent line, I drew the tangent line, I found where it hit the x-axis, and that's my next guess. And this is it right here. So the whole first part of your project, part A and B, is basically explaining this and rewriting this function, this Newton's method formula, okay? And here is the project. So in Blackboard, come on. Nothing works for me on this stupid. Surface Pro, Windows 10 is driving me crazy for some reason. Okay, so in our Blackboard page, on that sidebar, it's the project folder. There's two files in there, and the printer's working again. If you wanted to print one out today, you could. You don't have to. There's the instructions and the rubric. The rubric tells you what I want you to include in the project. And this is not written by me, someone at Rice University in Texas. I found the answers on the web, but in the rubric, there's a little bit more detail of what I want. Okay, so make sure you read the rubric. And this whole first thing, so you can see here the curve, you can see my initial guess, you can see I go up to the curve, I draw the tangent line, where it hits, that's my next guess, and then I repeat. Okay? So this is very much a computer programming type of thing. It's what it happens in your calculator. When you press pi on the calculator, it's calculating how many digits you want using this method. So, so part A and B, okay, are trying to get what I just gave you. So when you start reading it and go, oh my God, this is super nerdy, right? Realize that really I'm just asking you to come up with, hey, how do you find the next point? And then what's the formula for it, right? So that's all A and B are saying. Okay, so far? So they're just asking you in the project to come up with a nice version of it, right? And I did it. This is the nice version. What is the initial guess here is just an X. And then my next guess comes out of this right-hand side. Once I calculate this, it will give me the answer. That's what I start, that's what I do. I repeat, right? It's an iteration, right? So part C is us actually using it, right? So let's do that. So part C says I have 1 over x equals 1 plus x cubed. And they're asking us to find where these two curves cross. Of course, we could graph it, right? There's 1 over x. There's 1 over x cubed. Sorry, 1 plus x cubed. And they want us to find a positive root. Okay? They want us to find a positive root. So we know x is approximately equal to, by Desmos, y equals 1 over x, and y equals 1 plus x cubed. And there's my positive root, about 0.724. So let's take a guess at 0.7. Right? You get what I'm saying? I probably couldn't, but I certainly could look, right? I could certainly look and say it's really close to 1. I could probably guess 1. Yeah, exactly, just looking at it. So one of the questions is going to ask you, what's the reciprocal of pi, right? I mean, well, what am I going to do? I'm going to go 1 divided by pi, right? And okay, I got a number for the reciprocal of pi, but then I want Newton's method to come up with it. So we're not there yet. You'll see it in a second, okay? So what I have to do, so this is a good guess, right? 1 is probably a good guess too. 0 is a good guess. I know it's somewhere between 0 and 1. 0.5 is a good guess. So, so what I'm going to do is create a function here. This is going to be my f of x, and I'm just going to move that 1 over x on the other side, right? So I'm going to have an x cubed plus 1 minus 1 over x. There's my function. Remember, I need my function, I need my derivative, right? And I need an x. So let's get our derivative here. What is it? Agreed? So x next is going to be x minus f of x over f prime of x. Can we do anything with that? Say yes. What's that? Yeah. Can we make it lose a little prettier? Just an opinion, but what can we do to make this look a little better? X squared over x squared, right? Double check me, please. Oops, sorry. Made a mistake. That's just an x, right? Trying to get a single fraction. LCD. LCD. I have a 1 underneath that x right now. I want a 3x to the 4th plus 1 underneath it. Oops, sorry. 2x to the 5th, right? Minus x squared plus 2x. There it is, all over 3x to the 4th plus 1. Once we have a nice function to deal with, we're going to Excel. Anybody need a second? Need a minute, yes. Yep. Three x to the 5th minus x to the 5th. What? I multiplied it, right, to the x. So I kind of skipped a step here. I had x times 3x to the 4th plus 1 over itself, right? And then over here I have minus x to the 5th minus x squared plus x all over to 3x to the 4th plus 1. So no, they can't cancel. You're getting an LCD. You can only cancel from factors, right? Right. Okay, we have it. You got to do this algebra again anyway, but we need this piece. So we're going to Excel. If you want to do this with me right now, good idea. So opening up Excel. You could use, what is it, Sheets? What is it, Google Sheets? You could do that. You could do something else if you already know how to program in Python. You could do something in Python if you wanted. I don't care what you do. So we're going to put our initial guess here. And what did I say? 0.5 is okay, right? And we're going to get our next guess here. But our next guess was given to me by Newton. Yes? Sir Isaac Newton. So my initial guess was X on my paper, right? But now it's going to be A2. Can you see cell A2? So column A, row 2, right? So everywhere I have an X in my formula for X next, I'm going to write it as A2. So I want so equals parenthesis 2 A2 to the 5th, correct? Help me. Minus A2 to the 2nd, plus 2x, right? 2A2. All divided by parenthesis, 3A2 raised to the 4th plus 1. Uh-oh. I got a mistake. I think I have to do 2 times A2. It's getting confused. 2 times A2. 2 times A2. 3 times A2. Let me see if that does it. Yes. So anytime you're referencing A2, if you're multiplying by something, you need the star symbol to say multiply. Look at it again, okay? Can you see it there? I can't, I don't know how I can zoom. Control plus, will that make a page bigger? Nope. View, zoom, 200%, okay. No, it's not making my formula line any bigger, but 2 times, yes, you got it? So I'll write it here. Newton gave it to us. So 2 asterisk A2 raised to the 5th. Yes, you with me? Minus A2 raised to the 2nd plus 2 times A2, right? Divided by 3 star A2 to the 4th plus 1. Anybody get it typed in yet? Got the same number as me? I guess we could, but anyway, I didn't think of it. Watch what I do now. I want my next guess to become my new guess, right? So my new initial guess. So I'm just going to write equals B2, right? So it's copying that number from B2 over to my initial guess. And then I want to take this piece and fill down, so I can highlight the cells, and I hit Control D, it will fill them down. And I do the same with this piece. Control D will fill it down. Control D. Well, if you remember from Desmos, we had 0.724. Look how closely I got to 0.724 in one guess, in one new guess, right? What if we started it at 1? So I'm going to start my initial guess at 1. It almost instantly, right? And then, of course, 0.7 was probably the best guess, right? So this thing is searching for the roots, right, of the function. It's really cool if you take a look at GeoGebra. So geo, like geometry, and then the rest of algebra, GEBRA.org, geogebra.org. and I go to the search magnifying glass up there on the right, and I type in Newton's method. So when I want you to give me a graph, this Funk one is okay. When I want you to give me a graph, right, of how many tangent lines until you get to the solution, this is an easy way to do that, right? So you can see x sub 1 is giving me p1 and then the red tangent line. And then from there, I get x sub 2. That's going up to p2 to the pink tangent line. Right? You with me? And I can change my guess. I can change my guess on there. I can just slide the first guess, and it will change the tangent lines. So one of the versions of this will give you a nice graph when I ask you for a graph in the project. Okay? So you of course will write everything up, include the tables from Excel or Desmos, whichever you use. You certainly can handwrite it all if you want. You could take screenshots of the graphs and then cut them, paste them in, whatever you want. It certainly can be all electronic. I'd say typing it would take way too long with all the math notation. You may work in a group up to 3. So you may work in a group up to 3. You can work in a group of 2. You can work by yourself. I don't care. It's up to you, right? So I had said it would be kind of interesting if the mechanical engineers work together, if the computer scientists work together, but you don't have to, okay? And then I think I had said physics and double E, so you guys, right, can work together if you want. When I look at the next part of the project, so as my function changes, I have to change Excel, right? So you probably want to save it, do another sheet, right? That kind of thing. Yeah, which equation? This one here? Yeah. So you need everything here. You need it. You need the equal sign too, okay? Part C. Part C, as in cat. Okay? So I'm going back to the project here. Part C, I'm finding that root. I just did it for you, right? You just have to do the write-up. Yes? And it says it wants it to 6 decimal places, right? Part D, here's my new function. And B is going to be pi. So use Newton's method for this new function to find the reciprocal of pi. What's that? Yeah, yeah. So you're going to do the whole Newton's method thing again, right? Get the function, get the derivative, plug into the formula for x next, and then, but it tells you try two different starting points. Start at 0.5, and one reciprocal of pi is what? 1 divided by pi is about 0.3. 0.31830988862. But 0.3 is a good guess. They told you to start your guess at 0.5 and start your guess at 0.7. So do two times. One time it will work, one time it won't work. Part E is the trickiest part. You're going to not use numbers in this case. In part E, you're taking this guy, this formula here, this f of x equals b minus 1 over x, and you're going to look at the error and what happens to the error as you keep doing the problem. So this is part E. This is the tricky one. So error is your guess minus the actual over the actual. And it's in absolute value. We don't want a negative error. It's so b is pi, and they're asking you to find the reciprocal of pi. So I'm just going to call it 1 over b. Yeah. Now, this is the initial guess, right? So this is the initial error. But we want to see what happens to the error as we go another step. So the error, the next error is going to be x next in here. And so what does that mean? That means you're going to have the x minus f of x over f prime of x in there. And you will notice something happens algebraically from the first error to the second error. And they want you to show that the error gets squared. So part E is tricky because you're not going to put any numbers into it. You're doing it all algebraic. And the last part is part F. You have to do the calculations on a spreadsheet or something, but then how you write it up is up to you. Part F, there's 3 questions. If you work on it alone, just do one of them. If you work on it with 2 people, do 2 of them, 1 each. If you work with 3 people, do 1 each, right? And they'll all fail. So the idea is for you to tell me or show me why they fail, why Newton's method fails, okay? So you got about 3 weeks to get it done. I think I've had a couple of top students do it in about 4 hours max. So yes, question? Nope. ready to go. Say it one more time. Yes, you can. You can do whatever you want, but I wouldn't do that. Get it done as soon as you can. It's 10% of your grade. It will drop a letter grade if you don't do it. Yes, Ethan. Yeah, I have office hour every day. I'm here at 10:30 every day. So if you want to just send me an email, if it's not Tuesday, it can be after class. I'm here at 10:30 every day. If it's not a Tuesday, I can meet after class. Yes. If it's after class, not on a Tuesday, you could just say, "Can I ask a couple questions after class?" I'll say yes. If it's before class, send me an email just so I know where to look for you. I'd probably just say, "Let's meet here." Yeah, you can talk to me every day. You can talk to Dr. Early any day you want. You can go over to the Math Learning Center, right? Anybody want to do the project on their own? Don't want to work with anyone else? Nice. Do you want to do what I suggested, the engineers together, and no? Okay. So talk to each other if you want to work on the project, okay? Yeah, and you're ready to do this. We're ready to do chapter 4. I'm going to start it tomorrow. But the things I do tomorrow and Monday and Tuesday, they won't hurt you for the exam. Okay? You still need to be practicing for the exam, right? You still need to be asking me questions at the beginning of class. You should do all of the old exams, right? Oh, tomorrow I'm not. Tomorrow I'm going to review. So I'm just going to give you a fake test that I gave one semester that you don't have yet, and we're going to work on the problems and then go over them. Okay. But then Monday I'm starting chapter 4. It won't hurt you. You got to trust me on that. It's just more derivatives, and that's what you need practice on, taking derivatives. Yeah, Ethan. One more time. Yes. Chain rule for sure. Like a question like that one we did today we did the LN trick even, right? So one like that for sure. What was the other one? No, I don't have it open anymore, but it's okay. If you open up the chapter 3 test materials, that first test, there's a couple of good chain rule ones on there. So let's just say chain rule tomorrow. Okay, so, and then the rest of chapter 4 is pretty quick. 4.2, 4.3, 4.6, 4.8, only 4 sections really. I have an option of doing section 4.1, but I skipped it last semester, so I might skip it again this semester. The day of the exam 2, which right now is tentatively August 18th. It might turn into August 17th. How's everybody feeling about the project? I mean, I talked about it quickly, but I'm happy to talk about it again. So you could always say to me at the beginning of the class, Robert, I'm stuck on part E. I think I got the first error, but I'm not sure about the second error, that type of thing, right? And it's just, that one's just algebra. But students tend to want to put numbers in. That one is just going to be algebraic. And if you think about it, squaring an error is interesting. Why? What do we want the error to be? Error. Well, remember, we're finding an x value, right? So if the value is 3.14 and we got 3.13, we can calculate how off it is, what percentages it's off. That's the error, right? But if my error gets squared, why is that interesting to me? What do I want the error to be? I want the error to be 0, right? So if you think about it, when you square something very small, what happens to it? It gets smaller. So if I make the right choice and my error is less than 1, then it's going to just go to 0 right away. If my error is bigger than 1, what happens when I start to square it? It goes to infinity, right? Every time I do a new error, I square it. New error gets bigger, 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 bigger. So that's part E is hinting at that if you get an error less than 1, Newton's method is going to work. Yeah, so as you're working on the project, you can always send me stuff or you can ask in class, right? I want you working on your formula sheets because when you take the test, you may only have that one sheet of paper. No tablets, no laptops. You have to use the school computer. You can use a calculator, formula sheet, school computer. Desmos only.